Welcome to Study Loop.
Okay, we have the following substrate, and we're doing a series of reactions on this substrate. First up is CPBA, that is a peroxy acid, right? Turns alkenes into epoxides. Next, we have a Grignard reagent. Okay, we follow that up with, this is sort of a two-parter, so we're just counting this as 2A and 2B. So the first part of step 2 is the Grignard reagent, followed by acidic workup. And finally, we have hydrogen gas with the catalyst palladium over carbon. Okay, so what happens after the CPBA? I'll recall that we get an epoxide. So instead of a double bond between these carbons, we'll gain two bonds to oxygen. Okay, next we're going to install our Grignard reagent, and recall that in basic, or we should say non-acidic conditions, our Grignard reagent will always add to the less substituted carbon. So I'm going to color code things here real quick. Right, I'm going to say this carbon is red. I'm going to say this carbon is blue. Right, and I'm going to color code our Grignard reagent. So we see that we have a 1, 2, 3 carbon chain, or really a 4 carbon chain with our Grignard reagent magnesium bromide attached to the 1, 2, 3rd carbon. Okay, so the epoxide will open up. The blue carbon will maintain the oxygen. The red carbon will gain a new bond to our Grignard reagent. Right? And the carbon has a methyl group, another methyl group, and then a bond to a carbon with a double bond, like so. Next, we do acidic workup, which will turn our alkoxide into a neutral hydroxyl. However, the rest of the molecule will remain the same. Like so. And then finally, we're going to use hydrogen gas with catalyst palladium over carbon. And what this will do is hydrogenate any double bonds. That is, double bonds will be eliminated and we'll just be left with an alkane. And so our final product then will look like the following. Methyl, methyl, methyl. And then the more standard way of drawing this, I mean, this is perfectly acceptable, but if we think about it in terms of being a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain, then we might say 1, 2, 3, 4, 5, 6, 7, 8, right? With 2 methyls on carbon 3, hydroxyl on carbon 4, and on carbon 6, we have 2 methyls.